Okay, well, thanks a lot for the opportunity to do this. You pronounced our name ACIN. We normally say Acin. Acin Instrumenten, founded in 1967. I started working there in 2001 and became Chief Technical Officer in 2008. And became responsible for the development of instruments. And one of those instruments, now launched a few years ago, I think 3 years ago, is the Air Tightness Tester, which I'm gonna talk about now. And what is the origin of the Air Tightness Tester? It is the result of a project in the Netherlands that was running from 2017 to 2020, and it was initiated by TNO, Walter Borsboom. Probably some of you know him quite well. And there was the problem in the Netherlands that the equipment to really check a house was too expensive, in a typical Dutch problem. So they defined a project to get to develop 3 types of instruments for air tightness, for air volume flow, and for noise level, in order to make it more affordable and therefore more better available for the installer. And the idea was, Acin got the question to develop the 2 systems for air tightness and air volume flow. I'm not going to talk about air volume flow here. We developed the VentiFlow. You see me standing there with the VentiFlow to a non-zero pressure compensation, simple flow measurement, which does a good job on out and exhaust and supply valves. Because with our method, you need a volume flow measurement. And this method is this Air Tightness Tester. So, yeah, of course, we know air tightness is normally measured with the blower door. And we have developed the ATT based on a patented ID from TNO, from Hans Pfaff, brilliant researcher. And like Luc was saying, this method that we've developed is absolutely not meant to replace the blower door. It's really to supplement or to make other applications more easy. Therefore, that is what the ATT is doing. That is what the Pulse Test also brings to the market. So what do? The idea is to use the ventilation system of the house to pressurize the house. Now, if you have a heat recovery unit, you can do either supply or exhaust flow, and you can then pressurize, overpressurize, or underpressurize the house. And the ATT is just a reference vessel in which the basic base pressure is stored before you start turning on and off the ventilation system. So you see here the on-off or the high-low button. We can do that also. We can also switch between high and low flows if you can't switch off the ventilation unit. And what it does, you start the measurement by turning off the ventilation system, and then on that vessel of the ATT, a little valve closes and it stores the base pressure. And then you start turning on and off the system. So it makes smart use of the ventilation system, and it serves as a reference. And when you turn on and off the ventilation system a number of times, the pressure difference is measured. From this pressure difference and the airflow, so you also have to turn on the ventilation system for a while and measure in one way or another the airflow. You can do it on the valves, you can do it on the ventilation unit itself, but you have to measure it as if you are going to use it in the measurement itself. And you see here a measurement, a typical measurement, although it's quite smooth, quite a smooth one. where the ventilation is turned off and on about exactly 5 times. Well, of course, we have done testing. This is the testing of 2018 and 2019. We did much more testing. In the Netherlands, it's used, the QV10 is used, so the air tightness at 10 Pascal. And here is a nice one-to-one regression. The method really works well in these cases. We actually got also an award at a exhibition in the Netherlands, Verwarming, Sanitair en Klimaat, so heating, sanitary and climate. And here are a few points that they mentioned. The first sentence is nice. Air tightness is the dark horse of the energy transition. And I think also serial housing and apartments to be tested quickly is very important. And in that way, it's supplementary to the blower door test. Because what you can do is do a measurement with the ATT while you are also doing a blower door test. You can sort of calibrate your ATT measurement and then do all the other apartments. So it's really a tool that is supplementary to the blower door. I want to show here an example where the ATT was very useful. In the left corner, the left upper corner, you see a house without the dormer, and the big picture shows the new dormer that was built for this client. He is a guy that is changing his whole house by himself. He does the installation of HRU himself. He does the installation of solar panels and a very complicated system to deliver electricity to the net and to profit from all those things as much as possible. He does do a lot himself, and he ordered this new dorm on both sides of the house. And I was at the house when the dorm wasn't there. I did air tightness measurements, and I was at the house just last Friday to check the new situation, which is he is not ready yet. He didn't make everything airtight yet, but you will see that this is just to show you an example what the air tightness tester can do. Here is this heat recovery unit, and on the right you see the tablet, which is used to control the air tightness tester that goes over Wi-Fi. The air tightness tester is not in the picture, but you will see it later. The volume flow measure was in this case very easy, because what we did, we didn't turn on off the HRU, but we just lifted off the flexible tubing and put it back again. That way we could pressurize the house very easily. Here you see the air tightness tester, and on the left, on the left you see the screen with the settings. You can, before you start, you can enter all the information that you have on the house, and there is an important factor there, because it's a 1-point measurement. You need to know the flow exponent, or you need to estimate it. We take the 0.66, like in the American standard, and also which is a result of about 400,000 houses database air tightness measurements in France, for example. And otherwise, if you combine, like I was saying before, measurements with the blower door, you do 1 or 2 houses with a blower door, and then you do the rest with the ATT, you can actually have a better estimate of the flow exponent. You can enter some information on the building. It says here mechanical, that should have been balanced. And then you can start measurement. In fact, you see on the right, you see the ATT. The green light is burning, and that means that it is the valve is closed and it's already measuring. And you see that in this house we had about 440 cubic meters per hour airflow. So I show a little video what happens if you.
Rustig eraf halen.
So he now takes off the tubing. You saw the pressure being low, and there it goes back, the pressure to its base pressure. You see some trend in it, But of course, mathematics makes it very well possible to detrend this and to properly calculate the delta P. That's also why you repeat the measurement a few times to get a robust measurement. Oh, that wasn't meant to be. When we were there the first time, the house was very tight. It even unplugged some plugs from the electricity cabinet, and the little thing was floating on the air. Here's mine. So these were the results when the dormer was not built yet. And this is how also the program looks. You can choose your own units. You can, I didn't fill in the volume yet, but you can do that afterwards. And then you saw that this measurement, this particular measurement was quite good. We had about 32 pascals of under pressure at a flow. And this is actually a special measurement. We did this a bit different. We did this with the HRU on 2 settings. So we use setting 1 and setting 3 of the HRU, 445 minus 77 cubic meters per hour. And with an area of 125 square meters gives you a air tightness of 0.44 plus or minus 0.06. So that's a very tight house, and it was really quickly measured. Then the dormer was there, and you see that the construction is not ready yet. The ATT is on the floor. I'm in my hands with the tablet, and to the right you see the flow finder to measure the flow on the HRU. We just moved in the HRU before it is working. We use it as a blower, like in the blower door. And now this is what we got. And you see that the ATT is very sensitive, but this is only a few pascals, and like 5 pascals. So the dormer was absolutely not yet airtight, but it was interesting to see that we could do this measurement. And also, while you are constructing the dormer from step to step and isolating it and purring it and whatever, you can repeat this measurement to see if you are making any improvements. So here is the result of a measurement, 4.2 pascal plus or minus 0.5 pascal with an air tightness of 1.73, which is like about more than 4 times larger than the original one when the dormer was not there yet. So that tells you about, that is what I wanted to tell about the ATT. I think I really love to have some time to get questions. So I think this should show that the system has a nice potential. Okay, thanks.